Somewhere in a command bunker buried beneath the limestone hills overlooking the Strait of Hormuz on the morning of March 5, 2026, an Iranian general looked at a screen showing the position of the USS Abraham Lincoln and did not order an attack. He did not need to. The ship was already where he wanted it, 400 miles away. Outside the envelope, pushed back by the credible threat of weapons his country had spent 20 years building precisely for this moment. He had not fired a single missile at that carrier. He had not needed to. The carrier had moved on its own, repositioned by the invisible geometry of threat rather than by any direct engagement, and that, more than any battle, more than any exchange of fire, more than any dramatic confrontation between fleets, was the victory Iranian strategists had designed their entire anti-access doctrine to achieve. Not destruction, displacement. And on March 5th, 2026, displacement was complete. This is not the story of a missile. It is the story of a strategy assembled piece by piece across 2 decades by engineers and generals and planners who studied American naval power with the obsessive precision of men whose survival depended on finding its limits. They found them. They built weapons designed specifically to exploit them. And on the morning that 2 American supercarriers held position hundreds of miles from Iranian shores, every calculation they had made across 20 years was confirmed correct. What those carriers represent, what they cost, what they were built to do, and why they cannot do it from where they are sitting today, is the hidden story behind the most significant shift in naval power since the aircraft carrier itself made the battleship obsolete. And it begins not in the Persian Gulf, but in the rubble of a lesson Iran learned watching someone else's war. In 1991, Iranian military planners watched the United States Navy operate with absolute impunity in the Persian Gulf during Operation Desert Storm. Carriers moved where they chose. Aircraft launched from decks that no Iraqi weapon could reach. The sea was an American highway, and everything that traveled on it did so at American discretion. Iran looked at what Iraq had possessed, looked at what it had done with those possessions against American naval power, and drew a conclusion that would define Iranian military investment for the next 3 decades. Conventional naval competition was not merely difficult, it was impossible. Iran could not build the destroyers, the submarines, the carrier aviation, the logistics infrastructure, or the training pipelines that American naval supremacy required. But the planners looking at those satellite images of American carriers operating in waters that bordered their own country did not conclude from this that they were helpless. They concluded something far more interesting. They did not need to match American naval power. They needed to make it irrelevant in the one body of water that mattered most to Iranian national security. And to do that, they needed a specific kind of weapon, fast enough that defenses could not reliably stop it, cheap enough to produce in overwhelming numbers, precise enough to threaten the specific class of vessel that represented the center of American naval power. They needed an anti-ship ballistic missile, and they set about building one. The Khalij-Fars missile that emerged from that program is, in engineering terms, a weapon of elegant brutality. Its name means Persian Gulf in Farsi, and the naming was deliberate, a declaration of intent embedded in the designation itself. Derived from the Fateh 110 short-range ballistic missile, the Khalij-Fars carries a warhead weighing 650 kilograms of high explosive. It travels the bulk of its 300-kilometer range using inertial navigation, requiring no external guidance signal, no GPS uplink, no communication that electronic warfare can intercept or jam. In the final phase of its flight, descending its steep angle toward the surface of the water below, it activates an electro-optical seeker that searches for the thermal and visual signature of a large surface vessel, identifies the largest return in its field of view, and homes on it autonomously. No operator required, no further communication needed. The missile finds the ship. Iran has conducted tests of the system dating to 2011 and has publicly claimed perfect hit rates against ship-sized targets in the Persian Gulf. Western analysts contest the specific numbers. No Western analyst contests the underlying capability. At Mach 3, during its terminal descent, carrying 650 kilograms, it hits what it aims at. And 300 kilometers of range means every point in the Persian Gulf lies within reach of launchers that never need to move from the Iranian shoreline. What makes the Khalij-Fars not merely dangerous but strategically transformative is not the missile itself in isolation. It is what the missile does to the mathematics of naval defense. Each Arleigh Burke-class destroyer assigned to protect a carrier carries 96 vertical launch cells distributed among Tomahawk cruise missiles for offensive strikes, SM-series interceptors for air and missile defense, and anti-submarine weapons. Of those 96 cells, 16 to 24 at any given deployment are loaded with the interceptors, capable of engaging ballistic missiles. A carrier strike group built around the USS Gerald R. Despair R. Ford typically sails with 3 destroyers, giving the entire formation somewhere between 48 and 72 ballistic missile interceptors to defend against everything that comes at it. IRAN demonstrated in February 2026 the ability to sustain more than 100 ballistic missile launches in a single day. A coordinated saturation attack, 200 simultaneous launches from dispersed mobile platforms along the Iranian coastline, would exhaust every interceptor in that formation before half the incoming salvo had been engaged. Even at a generous 70% intercept rate under the worst conditions of simultaneous multi-axis attack, 60 missiles penetrate. 1 Khalij Fars hit will destroy an Arleigh Burke destroyer. 3 hits will sink it. A single hit on the carrier itself, striking the electromagnetic launch catapult or the arresting gear or the weapons elevators, ends flight operations on a ship that cost $13 billion to build and exists for no purpose other than to conduct flight operations. The Hormuz variants of the Khalij Fars family extend the trap in a direction that removes every clean defensive option from the American playbook. Hormuz 1 and Hormuz 2 are anti-radiation missiles, engineered to home not on a ship's visual signature, but on the electromagnetic emissions of its own radar systems. And this creates a dilemma with no exit. Aegis-equipped destroyers must keep their radars active to track incoming ballistic missiles, build intercept solutions, coordinate defensive fires across the formation. But active radar broadcasts the precise electromagnetic signature that Hormuz variants use as a homing beacon. The destroyer's defense system guides the missile to the destroyer. Shutting down the radar removes the homing signal, but also removes the ability to track incoming threats at all, leaving the formation blind at the moment it most needs to see. There is no configuration of choices available to an American task force commander in the Persian Gulf that does not accept serious, potentially catastrophic risk. The Hormuz variants did not just add a weapon to the Iranian arsenal. They removed an option from the American response, and the option they removed was the one that made Aegis defense work. The geography of the Persian Gulf is not incidental to Iran's strategy. It is the strategy's foundation, the physical environment that transforms every Iranian advantage into a multiplier while compressing every American defensive strength into something smaller and more difficult to sustain than it would be in open ocean. At its narrowest point, the Strait of Hormuz measures 21 nautical miles across. The Gulf itself averages between 25 and 250 miles in width. Aircraft carriers are built around the assumption of deep ocean operations, where defensive perimeters can extend hundreds of miles in every direction, where escort ships and aircraft have the time and space to identify and classify incoming threats at ranges that allow multiple intercept attempts before any threat reaches the formation. In the confined geometry of the Persian Gulf, that perimeter collapses entirely. Keshem Island sits at the mouth of the strait, so close to the central shipping lane that a missile launched from its terrain arrives at a transiting warship in minutes. Bandar Abbas occupies the northern shore of the strait, directly overlooking the only maritime passage into the Gulf, and launch batteries near the city cover every possible approach vector. Iranian coastal sites along the entire northern Gulf shore overlap in their coverage arcs, creating interlocking fields of fire with no gaps, no blind corners, and no safe anchorage that falls outside the range of at least one launch position. A carrier attempting to operate inside the Gulf would face incoming missiles from multiple directions simultaneously, with defenders required to engage threats arriving faster than any sequential response process can handle. The geography does not merely support Iran's anti-access strategy, it is inseparable from it, and Iranian military planners have spent 30 years learning to exploit every nautical mile of it. The timeline mathematics compound every other problem into something that approaches an absolute physical constraint. The Khalij Fars covers 300 kilometers in 3 to 4 minutes, from launch to impact. Satellite detection of the launch, communication of that detection to ships under threat, processing of threat data by Aegis combat systems, development of intercept solutions, and actual launch of interceptors requires, under genuinely ideal conditions with everything functioning exactly as designed, 60 to 90 seconds of that total flight time. That leaves 2 minutes, perhaps slightly more, for actual intercept attempts before the incoming missiles enter terminal phase. In terminal phase, the electro-optical seeker activates, the trajectory steepens beyond the engagement envelope of some interceptor variants, and electronic countermeasures lose most of their residual effectiveness against a target moving too fast for jamming signals to meaningfully alter its course. Any single failure in the detection and engagement chain, a processing delay, a communication gap, a targeting solution that requires one additional cycle to resolve, produces not a missed intercept, but a hit. These are not problems that better training addresses. They are not gaps that improved software closes. They are physical constraints defined by the ratio of missile speed to engagement timeline. And that ratio does not change based on how much money was spent on the ship being targeted. The production arithmetic makes the structural problem permanent in a way that no near-term procurement decision can resolve. Marco Rubio stated the numbers publicly, and they require no elaboration. Iran manufactures more than 100 ballistic missiles every month. The United States produces approximately 6 to 7 SM series interceptors every month. For every interceptor the American defense industrial base produces in 30 days, Iran puts 14 missiles into storage. In any sustained exchange, the side whose magazine empties first loses the ability to defend its highest value assets, and the side whose magazine empties first is not the side launching from hardened facilities buried in limestone hills along a 2,000-kilometer coastline. Every SM-6 expended stopping an Iranian missile over the Arabian Sea is an SM-6 unavailable for a contingency in any other theater. Every destroyer withdrawn to rearm at a facility, potentially hundreds of miles away, is a destroyer that has left the carrier it was protecting with reduced defensive coverage during the interval. The structural exchange ratio is not a tactical disadvantage to be overcome through operational creativity. It is a feature of the strategic environment that Iranian planners engineered deliberately into the program from the beginning, understanding that the goal was not to win a single engagement, but to make sustained American naval operations in the Persian Gulf region economically and operationally unsustainable across any extended time frame. Mobile launchers dispersed across the Iranian coastline and interior ensure that even the most intensive counter-battery campaign cannot eliminate the threat at its source. A launcher fires its missiles and relocates before American counter-battery response can arrive. Underground storage facilities near Bandar Abbas and other coastal positions protect missile inventories from precision airstrikes, ensuring that bombing campaigns can attrite but never eliminate the launch capability. Reconnaissance drones, feeding targeting coordinates to launch crews, compress the kill chain from target identification to missile impact into windows so short that American commanders have no meaningful opportunity to intervene between the moment Iran decides to fire and the moment the missiles arrive. The entire architecture of the system was designed around one principle: deny the United States the ability to suppress the threat before the threat can be used. And that denial is working. The USS Gerald R. Ford represents the pinnacle of what American naval engineering can produce in 2026. $13 billion of construction cost. The electromagnetic aircraft launch system, capable of accelerating fully loaded fighters to flying speed with greater precision and less mechanical stress than any steam catapult ever installed on a warship. A dual-band radar array that can track hundreds of simultaneous threats at ranges that made previous generations of naval commanders genuinely envious. Advanced weapons elevators, nuclear propulsion providing essentially unlimited range, a crew of 4,000 sailors trained to sustain combat flight operations at tempos that older carrier designs could never match. It is, evaluated against every criterion its designers used when they drew the plans, a masterpiece. And it is sitting in the Mediterranean, thousands of miles from the conflict it was deployed to influence, because every extraordinary capability it possesses was designed to project power outward. Not $1 of its $13 billion price tag was spent solving the problem of what happens when the threat can reach the ship before the ship can suppress the threat. The USS Abraham Lincoln in the Arabian Sea faces the same structural problem from a different ocean, outside the 300-kilometer range envelope of the Khalij Fars, which is precisely why it is there and not closer. But outside the range, envelope also means outside effective striking distance of the Iranian targets that American strategy needs it to threaten. Aircraft launching from the Lincoln against targets deep inside Iran require aerial refueling support for virtually every mission. Refueling adds tanker aircraft to every strike package, adds coordination complexity, adds vulnerability, adds time over target constraints that reduce the precision and the weight of fire that any individual strike can deliver. The carrier deployed to project power is projecting caution. The ship built to threaten is positioned at the distance from its targets that threat, not choice, determined. And the distance between the Lincoln's current position and the nearest Iranian coastline is the most honest measurement available of how thoroughly Iran's 20-year investment has achieved its intended strategic effect. The Fatah hypersonic missile represents the next phase of that investment, and the trajectory it describes for carrier vulnerability over the coming decade eliminates any remaining ambiguity about where this is heading. Unveiled in June 2023 and assessed as having achieved initial operational capability since, the Fatah travels at speeds between Mach 13 and Mach 15 during portions of its flight profile. Its maneuvering reentry vehicle executes course corrections during both the exoatmospheric and endoatmospheric phases of its descent, following no predictable ballistic arc and presenting no stable intercept geometry to the defensive systems it is designed to defeat. SM-6 interceptors were not designed for targets at those velocities. THAAD was not designed for maneuvering hypersonic re-entry vehicles. No defensive system currently deployed on any American surface ship was designed for the intercept problem that the Fatah presents. The glide phase interceptor, America's developmental response to this category of threat, has no deployment timeline before the end of this decade at the earliest, and adversaries will not pause their development programs while the American response matures. If the college FARs pushed American carriers to the edge of their effective operating range, the FATA, at full operational anti-ship capability, does not extend that problem. It makes it categorical. The only defense against a weapon that cannot be reliably intercepted is preventing its launch, which requires destroying mobile launchers, dispersed across strategic depth before they fire, which requires operating close enough to Iranian shores to strike them effectively, which is precisely where the Khalij FARs makes it too dangerous to be. The two missile systems do not merely add to each other in threat. They compound each other, each one closing off the defensive option that might have partially addressed the other, until the residual space available for safe carrier operations in the Persian Gulf region approaches zero. And every adversary watching this unfold understands that the compounding does not stop with what Iran has deployed today. Political considerations have historically pushed American carriers into deployments that pure operational logic might have argued against, and the current deployment reflects those pressures operating in real time. Carriers communicate resolve in ways that no press release, no diplomatic statement, and no congressional authorization can replicate with equal credibility. Their physical presence tells allies something about American commitment and tells adversaries something about American intent that words simply cannot convey. The decision to send the USS Gerald R. Ford to the Mediterranean in February 2026 was not primarily a military decision, it was a political signal dressed in military capability. The problem with political signals delivered through military platforms is that when those platforms must maintain hundreds of miles of standoff distance to survive, the signal becomes ambiguous in a way that undermines its own purpose. Allies who understand the tactical constraints driving that standoff distance do not see resolved and confident American power. They see a carrier that cannot go where it needs to go to do what it was sent to signal it could do. Adversaries who understand those same constraints draw a conclusion that is more pointed still. They see a limit, a boundary, an edge of the envelope beyond which American military presence cannot be sustained without accepting risks that American political leadership cannot absorb. And once adversaries locate that boundary with precision, their strategic planning begins to orient around it. The broader cascade of consequences from demonstrated carrier vulnerability extends through alliance relationships in ways that compound the strategic damage far beyond the immediate operational context. Japan hosts American military forces partly on the confidence that those forces could achieve meaningful military objectives in the scenarios where they would actually be needed. South Korea's extended deterrence relationship with the United States carries assumptions about what American naval power could deliver if deterrence broke down. Taiwan's defense planning must now grapple with the demonstrated reality that American carriers cannot safely operate in confined coastal waters against ballistic missile threats significantly less sophisticated and smaller in number than what China could generate in the opening minutes of a Taiwan Strait crossing. The revelation of carrier vulnerability does not stay in the Persian Gulf. It travels through every security architecture that American naval supremacy was supposed to make credible, introducing doubt where certainty was doing strategic load-bearing work. Allies recalibrate quietly. Adversaries recalibrate loudly in procurement budgets and operational planning, with new confidence about where the edges of American power actually lie. The multi-domain attack doctrine that Iranian military planning has built around these weapons does not rely on any single system achieving decisive effect on its own. It relies on the deliberate, coordinated overloading of a defensive architecture that was designed to handle one threat category at a time. The opening wave of ballistic missiles forces Aegis systems into their highest priority defensive mode and begins consuming interceptor magazines. Simultaneously, low-altitude cruise missiles approach from different azimuths, presenting radar profiles that blend into sea clutter and demanding defensive attention across multiple threat axes at once. Fast attack craft of the Islamic Revolutionary Guard Corps Navy, small, fast, and carrying anti-ship missiles of their own, close from multiple directions, forcing escort ships to divide attention between the air and surface threat pictures simultaneously. Mines, previously seeded through the shipping lanes, create additional hazard for any vessel attempting transit under fire. Diesel-electric submarines, optimized for the shallow and thermally complex waters of the Persian Gulf, positioned for torpedo attacks against vessels already damaged or stripped of escort coverage by earlier waves. Each individual layer of this assault is manageable in isolation, all of them arriving within the same narrow defensive time window coordinated to deny any single threat the concentrated attention it requires for reliable interception, create a problem that finite defensive magazines and finite combat system processing capacity cannot solve. The formation runs out of interceptors before it runs out of incoming threats. And what happens after that is not a tactical problem. It is a catastrophe. The cost-benefit arithmetic of risking a carrier in that environment is not complicated. The USS Gerald R. Ford is $13 billion of construction cost, 4,000 sailors, and the industrial capacity of American shipbuilding committed to a single platform across years of production. Losing it would constitute the worst American naval disaster since Pearl Harbor. But the material loss, enormous as it would be, is not the most consequential dimension of the risk. American strategic credibility, the belief held by allies and adversaries alike that American carriers can operate anywhere in the world, and that the flag they fly guarantees their safety through the threat of overwhelming retaliation, rests on the perception of invulnerability. A carrier sunk by Iranian anti-ship ballistic missiles would shatter that perception permanently and globally. Allies who have built their security architectures around the assumption of American naval supremacy would begin the painful recalculation of what American security guarantees are actually worth in the scenarios that matter most. Japan would reconsider, South Korea would reconsider, Taiwan, whose defense planning carries embedded assumptions about American intervention in a Chinese attack, would be forced to confront what it means that American carriers demonstrated they cannot safely operate in confined coastal waters against a missile threat, far less sophisticated than what China would generate in the opening hours of a cross-strait operation. China has been watching every repositioning, every standoff distance, every operational constraint that Iranian missiles have imposed on American carriers since this conflict began. The DF-21D anti-ship ballistic missile that China deploys has a range exceeding 1,500 kilometers, 5 times the reach of the Khalij Fars. The DF-26 extends that reach across the entire Western Pacific from launchers positioned so deep inside Chinese territory that no strike capability based on a carrier could reach them. China's ballistic missile inventory is measured in thousands, not hundreds, backed by targeting architecture, reconnaissance satellites, and over-the-horizon radar systems that Iran cannot approach in sophistication or scale. If the mathematics of defending against Iranian missiles with 300-kilometer range is already severe enough to keep American carriers at distances that hollow out their operational effectiveness, the equivalent calculation in the Taiwan Strait against Chinese systems is not a harder version of the same problem. It is a different problem entirely, at a scale of consequence that dwarfs anything the Persian Gulf represents, and every analyst in Beijing drawing conclusions from what they are. Watching in March 2026 understands exactly what those conclusions mean for the credibility of American commitments to Taiwan. The institutional resistance to confronting this, honestly, is powerful and deeply rooted in the structure of American defense. 11 carrier battle groups form the backbone of American global military posture. The annual operating costs of those ships exceed $15 billion before construction amortization and aircraft procurement are included. The defense industrial base sustaining carrier construction spans congressional districts across the country. The careers of senior naval officers are built around carrier operations and carrier advocacy. None of these interests make deliberately dishonest arguments for maintaining the carrier fleet. But they create structural incentives that shape how evidence is weighted, which questions receive serious analytical attention, and which conclusions get elevated to decision makers versus quietly filed in archives. The warnings about carrier vulnerability and anti-access, environments were available, clearly written, analytically sound, and consistently outweighed by institutional momentum for 2 decades. They are no longer available only in analytical reports. They are available in the current positions of 2 American supercarriers on a map of the Middle East, and the distance between those ships and the shores they were sent to threaten is a measurement that speaks more clearly than any analytical report ever could. The alternatives to carrier-based power projection that now carry greater strategic relevance each come with their own genuine limitations that intellectual honesty demands acknowledging. Virginia-class attack submarines at $3 billion each can operate in waters where no surface ship with 4,000 sailors and $13 billion of irreplaceable manufacturing capacity could safely venture. Their Tomahawk cruise missiles provide meaningful strike capability without placing a visible, politically consequential, high-value target within range of shore-based fires. But submarines cannot provide the visible, politically powerful signal of commitment that a carrier battle group communicates simply by appearing on the horizon. They cannot sustain the sortie rates across a campaign that carrier aviation achieves when operating without threat constraints. Their strike magazines are finite and cannot be replenished at sea, and their operational flexibility in responding to rapidly evolving situations on the ground is constrained in ways that carrier aviation, when it can close the distance, simply is not. B-2 stealth bombers, flying from Diego Garcia or from continental American bases, can reach targets that no carrier aircraft could approach safely, but they cannot maintain the continuous presence that sustained crisis management demands, and the sorties they can generate across days of operations are a fraction of what a full carrier air wing produces at tempo. Long-range precision strike from submarines and bombers can replicate some of what carrier aviation offers. It cannot replicate all of it. The honest strategic conclusion is not that carriers must be replaced. It is that the missions carriers were optimized to perform were optimized for a strategic environment that no longer fully exists, that the threat environment which has replaced it demands a distribution of strike capability across a broader portfolio of platforms than American naval planning has historically been comfortable accepting, and that making that adaptation while preserving what carriers do genuinely and irreplaceably well requires a level of institutional honesty about their current limitations that the defense establishment has so far found reasons to defer. Wednesday, March 5th, 2026, somewhere in a bunker beneath the hills above the Strait of Hormuz, an Iranian general is looking at a screen. The carriers are where he planned for them to be. The math is working exactly as the engineers designed it to work. 20 years of investment, of building, of testing, of dispersing launchers across a 2,000-kilometer coastline, of burying missiles in hardened underground facilities that precision airstrikes cannot reliably destroy, of training Revolutionary Guard crews to fire and relocate before counter-battery response can arrive, of developing targeting architecture that compresses the kill chain to intervals that deny American commanders any meaningful response window. All of it has produced this single, strategically decisive result. The most powerful navy in human history is keeping its distance. Not because it lost a battle, because it correctly assessed that entering the battle meant accepting risks that no responsible commander could accept with assets that no democratic government could afford to lose. That distance, measured in nautical miles between American carriers and Iranian shores, is the true monument to what Iran built. Not the missiles themselves, impressive as the engineering is, the distance, the invisible boundary drawn by the credible threat of weapons that cost a fraction of what they are keeping at bay, produced at rates that dwarf the production of the interceptors designed to stop them, and positioned with a geographic thoroughness that leaves no approach vector uncovered and no operating position inside the Persian Gulf genuinely safe. The era when American carriers could approach any coastline in the world without serious calculation of cost and risk has not been quietly undermined. It has been openly, measurably, permanently ended in the Persian Gulf. And the general looking at that screen on March 5th, 2026, did not need to fire a single missile at the Abraham Lincoln to end it. He just needed to have built the ones he already built, positioned where he already positioned them, in numbers that the mathematics of imperfect interception could not overcome, regardless of how much the ship being threatened cost or how many sailors were trained to defend it. The Squirter is the missile that slips through. But the deeper danger of Iran's Squirter doctrine was never the individual missile finding the gap in the defensive net. It was the strategic truth that the net has gaps, that any adversary willing to invest in generating enough volume will eventually find them, and that the cost of defending against volume is structurally higher than the cost of producing it. Iran proved that truth with 300-kilometer missiles. China is watching to prove it with 1,500-kilometer missiles, and the carriers are still retreating. What makes that retreat so consequential and so difficult to reverse is that it was not produced by a defeat. There was no battle, no fleet engagement. No dramatic exchange of fire that settled the question of naval supremacy in the Persian Gulf through the direct application of force. The carriers pulled back because the threat environment made presence too costly to sustain, and threat environments built from dispersed mobile launchers buried in limestone hills do not dissolve when the conflict ends. They persist. They will be there next month and next year and in the next crisis, requiring American naval power in the Persian Gulf region. The standoff distance that Iranian missiles have imposed on American carriers is not a temporary tactical condition pending resolution of a short-term problem. It is the new strategic baseline, the permanent geography of a region in which shore-based fires have redefined the boundary between where American naval power applies and where it does not. That redefinition did not happen suddenly. It did not happen because of a single weapons breakthrough or a single strategic insight. It happened because Iran spent 20 years making one correct calculation repeatedly, that the cost of building weapons capable of threatening American carriers was far lower than the cost of the carriers themselves. That production volume could substitute for technological sophistication in the saturation problem, and that displacement was a more achievable and more durable strategic outcome than destruction. They were right on every count. And the general in the bunker above the Strait of Hormuz on March 5th, 2026, looking at a screen showing 2 American supercarriers holding their distance, is the living proof of how completely right they were. The United States Navy will not acknowledge this officially. The deployment will be characterized as successful. Sorties will be counted. Readiness will be emphasized. The distances maintained from Iranian shores, and what those distances represent for what carrier aviation could and could not accomplish in this conflict, will receive less attention in the official accounting than the question demands. The next Ford-class carrier will be funded. The one after that will be funded. And the strategic debate about whether those ships represent the right answer to the threat environment that actually exists, rather than the one that made the investment, comfortable to justify when the plans were drawn, will continue to be subordinated to institutional forces that find the current trajectory easier than the reckoning it demands. But the distance does not lie. Every nautical mile between those carriers and the coastlines they were sent to threaten is a chapter in a story that the next war will finish writing. The Squirter that slips through a defensive net built to stop it is not just a missile, it is a proof of concept. And the concept it has proved in the waters of the Persian Gulf and the Arabian Sea in March 2026 is that the era of unchallenged American naval supremacy in contested littoral environments has ended, not with a battle, with a calculation. And the calculation was Iran's.